welcome to question 3a for the sample midterm of CS3340B. For this question, this is in fact a remake of an old video that had an incorrect solution where I used the algorithm in the slides for the KMP algorithm. Thanks to Matthew and Adroya, he pointed out that this is not the same algorithm, so there is a bunch of differences. You can see that the indices are tweaked, and this actually yields different results. So this is a remake of the solution. Okay, now looking at the string AB, ABC. Okay, now this is a 7-character long, so I ranges between 2 and 7 inclusive. Okay, so let's write that down. 2 less than equal to I less than or equal to 7. Okay. Now, next of I is defined to be the max j for j between this range. Now, I prefer to rewrite the range so that it's inclusive. This is much easier for me to process. Okay, so you have 1 less than equal to j less than equal to I minus 2. Next, we try to compute the next of I for a bunch of different i's, starting from, well, okay, next of 1 is given to be -1, so let's just write that down there. Next would be next of 2. Next of 2 is defined to be the thing that matches this condition. So actually, how about I show you something? So in order to do this, what you want to do is look at the maximum j here. So how actually I make some scratch work. Next of 2. Okay, so with that, I can adopt this inequality so that we have j is in the range what? Well, if we put 1 less than or equal to j, so less than or equal to I is 2, so j is between 1 and 0 inclusive. And you see the equality is reversed. Maybe this one is not so obvious. So if you look at the inequality here, you notice the problem. When I is equal to 2, you have 2 minus 1, so you have 1. So 0 less than j less than 1. There is no number between 0 and 1. So actually there is nothing. So in here, j is empty. Okay? So there's nothing to return, so we could just return 0 in this answer. Okay? There's just nothing we can do. Alright, next is next of 3. Okay, for next of 3, if we adopt the inequality here, plugging 3 minus 2 is 1, so j is between 1 and 1 inclusive. Well, there is just 1 here. Okay? Alright, then using this, what we can do is examine the string here. So this is what we're going to be the thing that we're going to compare to. Okay? It must end with pi minus 1. Well, I is 3, so it ends with p2. p2 is b, so I'm going to write b. It starts with pi minus j, j is the max. What's the max? 1. So, 2 minus 1, let's actually consider that again. Right, so it's next of 3. So it's actually 3 minus 1. Yeah, 3 minus 1. 3 minus 1 is just 2. So this is p2. So you can see that, oops. This one is p2 and this one is p2. It means there's nothing in between. Okay? So that's it. It's just b this is a string that we compare to. Now, we have to range j over this set. Well, there's just one, so there's only one thing that we can use. What is that thing? Well, it's specified by the string over here. So you have p1 up to pj. Now, j is 1, so it's actually none of that, just p1. Okay? So we can just write a. And now we ask ourselves, is there a match? Nope, there is no match. And that's it. The search is done. So we put a 0. Okay, next we examine next of 4. For next of 4, we're considering j over the set 1, 2. And how do I get 1, 2? Well, look at the inequality here. All you gotta do is put 4 minus 2. You have j inclusive between 1 and 2. That's just basically 1, 2. Alright, now with 1, 2, what do we do? First we need the string that we compare to. The string that we compare to is on the right hand side. It ends with p 4 minus 2, which is 4 minus 1, sorry, which is P3. P3 is A, so we write A. What does it start with? Well, the right-hand side starts with Pi minus max j. So the max j is computed to be 2. So 4 minus 2 is 2. So it starts with P2. P2 is B. And that's it. There's nothing between P2 and P3. That's our string that we compare to. Now the left-hand side, we compute it by arranging j. We arrange j over the set on here, which is 1, 2. So then we start with j equal 1. When j, well actually it's easier to start with j equal to 2. The reason is because we don't have to search everything. We start with the max j and go to the min j. As soon as we find a match, we stop the search. Okay, so I will start with j equals to 2. When j equals to 2, I have AB. So yeah, I have AB, you can see that. P1 up to P2, so that's AB. There is no match. Next, I go for j equal 1. When j equal 1, I only have an A. You align that with the suffix, okay? You align it this way, and we compare. So let me just draw that. And you can see there's an A with the thing that we compare to, and an A here, so that's good. There's a match, and j is equal to 1, so we put 1. Alright, next we do is next of 5. So then j ranges in the set 1, 2, 3. How did I get that? Use the inequality here. So if you plug in I equals to 5, 5 minus 2 is 3, so j is inclusive between 1 and 3, means j is in 1, 2, 3. So if j is in 1, 2, 3, what do? Well, first we want to compute the string that we compare to, which is the right-hand side. It ends with what? Pi minus 1, which is B. If we put 5 minus 1, that's P4. P4 is B. Okay, what does it start with? It starts with Pi, which is P5, minus the max j. The max j is 3. So 5 minus 3 is 2, which is B2. So we start with B. So you can see it's from B up to, oh actually I can just use this, from B up to, so this is P2, up to P4, which is again B. That's BAB. Now we start from the max j, so this time I'm going to write them so you can see. So j equals 1, well no, j equals 3. When j equals 3, we have to use the the left-hand side, so P1 up to P3. P1 up to P3 is here, ABA. So ABA. There is no match. Okay, so maybe that's not a good idea to write it here. The next one is j is equal to 2. When j is equal to 2, I have P1, P2, so it's just AB. Write AB, align it with the suffix, and there is a match. See, AB, AB. We're done. We don't have to look any more, so we just write 2. Okay, now we do next of 6. Alright, so j is in the set 1, 2, 3, 4. How do I know this? Adopt it from this inequality. And then, I'm gonna have to move this stuff below. Let me just move that. Should be good enough space for now. Alright, so j is in the set 1, 2, 3, 4. And then we look at the string to compare to. The string to compare to of the right-hand side ends with P5. P5 is this over, oops, this over here. And it starts with Pi minus j, and we pick the max j, so we end up with the second letter. It's always second letter for this algorithm. So the letter that the string that compared to is BABA. Okay. Now we start with the max j because it's easier. So the max j is 4. And then we go to here. We look for P1 up to the max j. That would be this string over here. AB, AB. So AB, AB, there is no match. Okay, next, j is equal to 3. When j is equal to 3, I look at only the first 3 letters, so that's ABA, and I match it with the suffix. And I have a match. So I stop the search and I'm done. Alright, and finally we do j next of 7. Next of 7, we conclude that j ranges over the set 1, 2, 3, 4, 5. So then we start from the second letter as usual. So the second letter being B, right? And then we continue up until the thing before that. So yeah, start from B up until I minus 1, so up until 6. Alright, so this is the string that we compared against, and I have my j's. I start with the max j, which is 5, alright, and then I take the first 5 letters of my original string. The first 5 letters are AB, AB, A. We see there is no match. Okay, next we move on to the smaller j, which is 4. Okay, for here, what you're going to do is take P1 up to Pj, so j is 4, so we have A, well, you have to also align it with the suffix, so that would be A, B, A, B, and we can see there is a match already, so that's good. So the answer is 4, and I've already filled in the table in here. So that completes the question.